All right, so next up, we're actually going to be looking at another one of these kind of cute little river crossing riddles that are going to give us some early motivation for identification of different types of states and how we transition between these. What are some valid moves? What are not valid moves? What's an initial state? Where are we ultimately trying to get to? And if we can actually train some type of machine to actually solve this thing. So the question in front of you is actually a slight adaptation to a classic problem that involves taking some people from one side of the river and moving them over to the other side of the river. The game here is that the people on the left-hand side are in one of two categories. They're either going to be a missionary or they're going to be a cannibal. So the twist here is that if there's an imbalance between cannibals and missionaries, that is, if we have too many cannibals, they're going to begin eating the missionaries because they don't have enough people to defend themselves, or however the game is going to be set up. Another twist here is that the boat's only going to be allowed to carry 2 people, because if the boat allowed to carry 6 people, all 6 would just hop in the boat and they would cruise on over to the right-hand side, and everything is great. So that's the game. I mean, these riddles all basically take the same shape, is that you're going to have some collection of people on the left-hand side. We're going to have to bounce between a bunch of valid states to try to ultimately get it where everybody is on the right-hand side. Naturally, you're going to know that there's always going to have to be at least one person in the boat. You can't ever just send an empty boat across. So if you get it to a position where you're at some type of nice balance, you're still going to have to think about how are you going to go back to the left-hand side to pick up somebody and transition that afterwards. And we'll chat a little bit more about that as we try to actually dive into the little riddle, but just things to be thinking about in the back of your brain. So this particular question, again, kind of takes a whole bunch of different flavors. I like presenting it as the missionaries and cannibals just because it's kind of weird because, I don't know, it's cannibals eating missionaries and I get to draw some missionaries with some fancy little, wizard hats, and cannibals, for whatever reason, are going to then be presented with some top hats because I like drawing stick people and I like drawing stick people with various, forms of hat wear. You could also have wizards or whatever you want it to be. Typically, or I guess not typically, but historically, this question is actually usually presented as the jealous husband's problem. So the game here is that you're going to have 3 couples. So you're going to have 3 husbands and 3 wives, and we're going to have to move from the left-hand side over to the right-hand side. And the issue here is that you can't have an imbalance between men and women, or various things are going to transpire. I like the game of cannibals and missionaries because cannibals eating missionaries seems just kind of weird, so we're going to go with that one. So I want you to kind of think in the back of your brain a little bit about how you would try to run this, as well as some possible difficulties that may kind of transpire. Then we're going to run through this kind of as a solution, show you the nice little graph, and then I'm just going to really briefly mention some different ways to encode this. I don't want to dive too far into the encoding process. We'll get more of that as we kind of build up some additional machinery, but I want to present it just so that's in the back of your brain as different ways to actually implement some of these things. I want you kind of leaning on all your different types of data structures, all the things that you know and love. Always be running that in the back of your brain as you're drawing out these little diagrams and all the things that come into play. Okay, so let's go ahead and try to see if we can actually come up with a cute little solution here. So what's in play? We have 6 people, which I have identified as MMM and CCC as missionary, 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 cannibal, 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 and I'm not actually giving them specific names. I mean, you could call it missionary 1, missionary 2, missionary 3, and cannibal 1, cannibal 2, cannibal 3, or you can give them cool sounding missionary and cannibal names, but for now we're just going to call them MMM and CCC, which is actually a slightly interesting aspect in that we actually really don't care if there's an organization within the missionaries. We just want to know how many missionaries there are and how many cannibals there are. So I wouldn't actually need to individually identify them. I could just put them in a group and keep tab as to how many there are. So again, be thinking about that as different types of implementation. You wouldn't have to store this as some little list of 6 entries. You could actually just store this as number of missionaries, number of cannibals, and move from there. Okay, so let's see one possible solution. And there are a couple different ways, and you can kind of see different turns that we're going to take as we run this. And I tried to keep the same kind of zigzaggy structure that we had in the Farmer Riverboat crossing because it's more or less the same game. And if you have a nice little system embedded for one, you can theoretically reuse that for something else. And now you have solutions to every possible river crossing problem. So what we're going to do first off is we're going to move some missionaries and cannibals over to the right-hand side. So one of each, let's say. Doesn't have to be your first move, but that's going to be the one that we're going to take. What we're going to do next is we're going to then send a missionary back. And you can see that that basically becomes the only move you can do backwards. Well, I mean, technically you could send the missionary and the cannibal back, but that does nothing because you're right back to the starting state. If I were to send the cannibal back, I would have a problem because once that cannibal got to the left-hand side, I would have 3 cannibals and 2 missionaries, so somebody's getting eaten. So I have to send the missionary back. So again, it is a riddle, but if you stop and think about it, some states have only one option out of it. And a lot of times the ones that have multiple choices are just going to lead into multiple solutions. So they're actually not that complicated once you kind of write out all of the little states and all of the possibilities between them. You realize that there's really only one solution, or maybe 2, but it's exactly the one that it has to be. Okay, so we're sending that missionary back. So now we're at the left-hand side where I got 3 missionary and I have 2 of these nice little cannibals. So we technically have some choices here in that you can send some things around. I'm going to choose to send 2 cannibals over. The idea is that I'm going to try to get all the cannibals over on the right-hand side and then slowly try to bring the missionaries back. It's kind of a first move that maybe makes sense. It's like, okay, deal with the problem people, kind of get them over there, and then we'll try to bring the missionaries kind of one by one, but keeping the balance in check. Obviously, there's some flaws by just bringing all the cannibals and then trying to bring the missionaries one by one, is that we're kind of slowly just feeding the cannibals, but we'll figure that issue out as we go. So I'm going to bring all the cannibals over to the right-hand side. So all 3 of them are sitting there. Well, the boat has to come back now, so I have to send somebody back. So I'm going to send 1 cannibal back, and now I'm sitting with 3 missionaries and 1 cannibal. And now I can bring 2 missionaries over to the right-hand side because there are 2 cannibals over there. So I can bring 2 missionaries and nobody's going to get eaten. So that's what I'm going to do. 2 missionaries get sent over. So now you're sitting with 2 missionaries and 2 cannibals on the right-hand side and a missionary and a cannibal on the left-hand side. So some things to note here is that if I would bring 1 missionary back, so let me zoom in on this guy right here. This is kind of a key step, I guess. Maybe not key, but some things to note is that you really only have 1 choice. So it may seem like there's a bunch of options here, but you really only got 1. If you send 1 missionary back, the right-hand side would have 2 cannibals and a missionary, i.e. missionaries getting eaten. And if you sent 1 cannibal back, the left-hand side would have 2 cannibals, 1 missionary. So again, a missionary is getting eaten. So your really only choice is to either send both missionaries back, but that just undoes what you just did, or you can send a missionary and a cannibal back. So again, it may seem like you have a lot of choices at this point in time, but you really only have 1. And that is to send a missionary and a cannibal back. So now we're sitting at this stage, and you have this over on that right-hand side. Again, so you have this game of what can you send, what can't you send. I'm going to try to get all the missionaries over now. So I'm going to send 2 of them over. So you're going to send 2 missionaries, which leaves 2 cannibals on the left, and you have 3 missionaries on the right. And now what's going to happen is basically we're going to undo that process that we did before. So we had kind of all 3 cannibals on the right. Now we're going to end up actually having all 3 missionaries on the right. So we're going to send a cannibal back. Again, at that point in time, you really only have that as your only choice, because if you were to send a missionary, it's going to get eaten. If you send a missionary and a cannibal, it's going to get eaten. So you really only can see that you have 1 choice, which is to send that single cannibal back. And now you're at the stage where they're, again, completely split. And now it actually spirals pretty quickly, is that it's pretty easy to move all the cannibals over. So you're going to try to move 2 of them back. And then you send a missionary over to go pick up the other cannibal that was left over, and exactly at your final state. So they're kind of fun. They take a little bit of thought, but if you sit and think about them long enough, they really don't have that much thought. I mean, that's the goal in all of this, is that we want to have riddles that don't actually require any thought at all. We're going to push this into a machine, and as long as we got the machine set up really nicely, it's going to churn out a solution. So we have to get it to a stage that the machine can actually understand, and we have to get it where the machine actually knows what's a valid solution. So once we're in kind of our final state, that's the goal in all of this, is to build up these cute little kind of finite machines that are going to run through all these possibilities in a somewhat clever way and kick something back to the user. So that's the missionary and cannibal problem, and it's kind of cute. There are nice little generalizations. In one of your activities, you're going to see a version of this where we up the number of missionaries and cannibals, we make the boat a little bit bigger, and you basically run through the same process again of kind of what can you do, what can't you do, kind of burn through all of those little options. In the next video, I'm going to run through, again, this kind of process of trying to actually see some of the underlying ways that you could encode this. and then jump into another kind of cute intro example, and then kind of give us a nice little overview of what's to come.